Hello students, in today's class we are going to discuss the formation of stationary waves in open pipe. So to understand this concept, you should know what are stationary waves and what is an open pipe. And in this we are going to discuss the harmonics as well as overtones also. So we should know what are harmonics, what are overtones, what are stationary waves, what are nodes and antinodes before going or before studying this concept of stationary waves in an open pipe. So let us discuss one by one, then actually we come for the main concept. So here, the formation of stationary waves in an open pipe. So first we go for what is a stationary wave, what are nodes and antinodes. So here, when one wave is moving in this direction and another wave is moving in the opposite direction, and these two waves, when two waves travels in the opposite direction, and these two waves, of course, they should have the same amplitude and same frequency. Condition is there, they should have the same amplitude and same frequency. When these two waves having the same amplitude and same frequency, they superimpose on each other. How they superimpose? They get superimposed by traveling in the opposite direction. This opposite direction is also important. So here, if I take, this is the direction of the first wave and this is the direction of the next wave, second wave. So if you observe here, what we are getting loops, and this we are calling it as the stationary waves, and in sometimes we call it as the standing waves also. So if you analyze this carefully, this stationary waves, here you are getting some points you are getting here. And these points where the amplitude is minimum, I can say the amplitude is minimum almost zero. These points we call it as nodes. This is also a node. And this is also a node. The point where the amplitude is zero is called as a node. Now, if I consider the points where the amplitudes are maximum, you can see the amplitudes here, they are maximum amplitudes we are getting. So these points where the amplitudes are maximum, they are called as antinodes. They are called as antinodes. All these points here, this is antinode, this is antinode. So this is one antinode, this is another antinode, this is another antinode. So where the amplitude is maximum, that is what I can say, that are the amplitude jahan pe maximum hota hai, that is called as an antinode. And where the amplitude is minimum, that is I can say zero, that is called as a node. The very important thing what you need to remember here is the very important thing. Now suppose this I consider just one loop, just I am considering one loop here. So this is what you call it as a node. This is also a node. If I want to know what is the distance between these two nodes, the distance between these two nodes is always lambda by 2. That is half of the wavelength. Now, if you continue this, what is the distance between this node and this node? That is also lambda by 2. And you know, student, this is what antinode. This is also an antinode. This is antinode. And this is also an antinode. So what is the distance between these two antinodes, consecutive antinodes? That is also lambda by 2. यहाँ से लेकर यहाँ तक भी lambda by 2 ही होगा. So here you need to remember the distance between the two nodes and the distance between the two antinodes are always lambda by 2. This is two nodes, lambda by 2, two nodes, lambda by 2, two antinodes, lambda by 2. Now my question with you is, what is the distance between a node and the next antinode? So the distance between a node and the next antinode, you can see here, this is just lambda by 2. Is it not half of this? Just you can see, I'm asking you the question, what is the distance between a node and the next antinode? That is half of the loop, half of the loop. So this distance you can see clearly, this is lambda by 2 total, it is half of that, so this will become lambda by 4. All the points are very important for to understand the formation of stationary waves in an open pipe. Okay, so this is about this just an stationary waves. And in these stationary waves, we should know what is a fundamental frequency, what are harmonics, and what are overtones. So fundamental frequency means if any object, if any vibrating body, I can say, it gets vibrated, it vibrates with its own natural frequency. That frequency we call it as a fundamental frequency. Now coming to what are harmonics and overtones. So let us understand by taking an example. Clear here, board? Students, we were discussing about the harmonics. What are these harmonics? Frequencies which are integral multiple of fundamental frequencies. So fundamental frequencies, let us take an example. First, I'll write the definition. Frequencies which are integral multiple So frequencies which are integral multiple of fundamental frequencies, they are called as harmonics. So for example, here you can consider an example. If suppose I take the fundamental frequency n, or we can denote it by f also. If this is the frequency, I'm considering it as 100 hertz. That means when a body is vibrated, it is vibrating with its own frequency, that is called as the fundamental frequency. It is as 100 hertz. Now, what do you mean by harmonics? So I take the definition, I take the help of the definition, that is frequencies which are integral multiple of the fundamental frequencies. So here, what I do, this is an integer, means like 1 into 100, integral multiple, that is 2 into 100, 3 into 100, and so on. That is what I can say: 100, 200, 300, of course, hertz, every with units. If you want to mention, you can mention with units also. So these are called as harmonics. These are the harmonics for n is equals to 100, that is the fundamental frequency, n is equals to 100. Now, if you go for the another term, that is overtone. What do you mean by overtone? Let us see. What is this overtone? Any frequency greater than fundamental frequency. So if you see here, this is an example I'm taking: 100, 200, 300. This 100 is the fundamental frequency. But what do you mean by overtone? Any frequency higher than the fundamental frequency. The higher than the fundamental frequency means 100 is the fundamental frequency. Higher means it is 200, 300, and so on. They are called as overtones. That is 200 hertz, 300 hertz, and of course, if you continue with this, that is 400 hertz are overtones. So here you have to remember three things for the formation of stationary waves. That is, first one is, what is a stationary wave? When two waves moves in the opposite direction, having the same amplitude and same frequency, and superimposing on each other, we are going to get a stationary wave, that is also called as a standing wave. Now, the distance between the two nodes, it's lambda by 2. Two antinodes is also lambda by 2. A distance between a node and the next antinode, that is lambda by 4. Now, coming to what are harmonics and overtones. Harmonics, they are like for frequencies like integral multiple of the fundamental frequencies, they are called as harmonics. The example I have given you. Overtone means any frequency greater than the fundamental frequency, that is called as overtone. Hope you have understood. Students, we have seen what are stationary waves, what are harmonics and overtones. And these stationary waves, how they get formed in an open pipe, we are going to discuss. So before going to for this again, you should know what is an open pipe. So for this, let us see the definition of the open pipe on the board. So here you can see an open pipe is a tube with both the ends open. One open pipe is a tube, and here the tube, if you consider that, you can say that both the ends are open. When a wave is passed into a tube, it gets reflected at both the ends. So here, whenever the waves are passed, the reflection will take place at both the open ends of the tube. For example, just you can see here, this you can consider as an open pipe. This is an open pipe where both the ends are open, and the reflection of the waves are taking place at the open ends. These are the open ends. So reflection will be taking place at these open ends. Next, hence the incident and the reflected waves are superimposed and a stationary wave is formed. Antinodes are formed at both the ends and nodes are formed at the center of the pipe. So whenever open pipe is there, not for this situation, whenever the open ends, I can say, whenever open ends are considered, there always antinodes are formed. And in between, we are going to get nodes. And at the close end, this is not the close pipe, but at the close end, always we expect node. Always antinodes are formed at the open end. So let us move with what we are going to discuss is the fundamental frequency. First is the fundamental frequency. Fundamental frequency. And this fundamental frequency is also called as first harmonic. This fundamental frequency is also called as first harmonic. Now for this, what we are doing, we are considering one pipe. And you know, as per the definition of the open pipe, always antinodes are formed at the open end. So for that, what we do here is we consider like this. This is an antinode. The wave is getting reflected at both the ends. Yeah, this is like this. And this is the first situation what we need to study. The wave is moving like this. It is getting reflected like this. They are getting reflected here. So here, this is called as an antinode. Here, this is also an antinode. Here also an antinode. This complete thing is called, we are complete this complete say this one we are calling it as antinode, and here we are, this is called as a node. So first point what I would like to write under this situation is how many nodes and how many antinodes are formed. So in this, that is what you call it as the in the first harmonic, in first harmonic, one node and two antinodes are formed. Now, for this, what I do, students, suppose this what you call it as AB. This is the pipe AB, and the length of this pipe I consider it as L. Try to understand, the length of the pipe is L. The ends are AB, the length of the pipe is L. Now, you can see clearly this is half of the loop. So half of the loop means how much is the distance in terms of wavelength. So this will be lambda 1 by 4. Why I'm taking lambda 1? Because of the first harmonic. So therefore lambda 1 by 4 from here to here. And from here to here again lambda 1 by 4. Why? Because this is also half loop, lambda 1 by 4. This is half loop, lambda 1 by 4. The reason here is just now we have seen the distance between an antinode and a node, lambda by 4, or a node and next antinode, that is also lambda by 4. Half of the loop wherever you are getting, you have to consider it as lambda by 4. The distance is lambda by 4. When you are considering two nodes and two antinodes, always it is like lambda by 2. Now, what is we are getting, what we are observing under this situation, in a first harmonic we are getting one node and two antinodes, whatever the first point we need to write. The next one, what we have to consider, the simple process, AB is equal to L. You can see the length AB, length of the pipe, I have considered it as L, but this AB in terms of wavelength I want to express, that is lambda 1 by 4 plus lambda 1 by 4. Lambda 1 by 4 plus lambda 1 by 4 is equals to L. Now you take the LCM for this. LCM is 4. Lambda 1 plus lambda 1, 2 lambda 1, that is equals to L. This is 1 times and this is 2 times. So lambda 1 by 2 is equals to L. So I am getting lambda 1 as 2L. So lambda 1 under this situation, it is 2L. Now, what I do here is, we know that this like one condition is there. We know that already, we know it. That is, velocity is equals to frequency into wavelength. Velocity is equals to frequency into wavelength. Because we are discussing the first harmonic, I take lambda 1 and F1 and lambda 1 I am considering. So what is this F1? F1 is V by lambda 1. F1 is V by lambda 1. What is lambda 1? That is 2L. So this is the expression for the fundamental frequency or the first harmonic. Now let us go for the second harmonic. Second harmonic, let us see what is the second harmonic. See students, I am writing here what I can say, the second harmonic or the first overtone. Just now I said any frequency higher than the fundamental frequency, that is called as overtone. So either it is a second harmonic higher than the fundamental frequency or the first harmonic, that's why I'm naming them as the first overtone also. So how to move with this? The same process is there, but here what you have to remember, this situation is over. The next situation, what we can expect here, you can see this is the next situation. So here I consider the length here, the length AB, and the length of the pipe is L only. Now you can see clearly this is one antinode, this is another antinode 2, and here antinode 3. Three antinodes are formed, and this is a node, this is also a node. So two nodes and three antinodes are formed. So the first point, without any like thinking, we should write the first point as in second harmonic. In second harmonic, two nodes and three antinodes are formed. Two nodes and three antinodes are formed. Now let us express the length of the tube in terms of the wavelength. So you can see clearly this is half of the loop. So therefore I take here lambda 2 by 4. Now you can see clearly this is one loop. So from here to here, I can consider, I'll write just antinode just here, and I'll consider from here to here, it is lambda 2 by 2 from here to here. And of course, from here, lambda 2 by 4. So this is lambda 2 by 4. This is also lambda 2 by 4. So in this situation, what I can do here is AB, again, AB is equals to the length of the tube. So what is AB in terms of wavelength? We can write lambda 2 by 4 plus lambda 2 by 2. This plus this plus this. So this is what lambda 2 by 4 is equals to L. That is the length of the pipe. Now, if you take the LCM, what we are getting, see, if I take LCM 4, this is lambda 2, this is 2 lambda 2 plus lambda 2 is equals to L. So it is totally what I am getting it as 4 lambda 2 by 4, that is equals to L. 4 get cancelled. Lambda 2 I am getting it as L. Now the same process we know that we write for the second frequency, that is second harmonic. We know that V is equals to F lambda. But what is this F lambda? That is for this second harmonic, I'm writing F2 lambda 2. So F2 is equals to V by lambda 2. That is F2 is equals to V by, this is lambda 2, right? So lambda 2, we can write it as L. Pay attention. Lambda 2, we can write it as L. So therefore, I'm just replacing that by L. And one more thing, after replacing this, I want to express this frequency F2 in terms of F1. But F1 is V by 2L. Here we are having just V by L. Try to understand, this is V by 2L and here it is just V by L. So for that, what I do here is I'll just multiply and divide by 2. So this is multiplication and this is the division. This is the division. Again, 2 to get cancelled, we are going to get the same thing. So what I am getting here is F2 is equal to, this is 2, and what is this? V by 2L, that is F1. That is the second harmonic is twice the first harmonic. So let us go for the another situation. Third one. Third harmonic. Or this is also called as second overtone. Third harmonic or second overtone. So for this, let us go what is the situation we are going to get after this one. So for that, I'll draw a pipe here. So these are the open ends, so antinodes must be there. So this is the situation already we have seen. So next situation will be, it will be like this one. So this is the situation what we are going to get. So again, I take this is A and this is B and the length of the pipe is L. So how many nodes we are getting here? You can see clearly 3 nodes we are getting. Nodes. And how many antinodes we are getting? This is one antinode. This is second antinode. This is third one. And of course, the last one, that is the 4 antinodes. So under this situation where we are calculating the frequency of the third harmonic, that we are seeing that in this situation, we are getting 3 nodes and 4 antinodes. And let us express the length of the pipe in terms of the wavelength of the wave. So how to express this? This is the half, right? So this I will take it as lambda by 4, but because it is third, so therefore I will write from here to here, I will take it as lambda 3 by 4. And this is complete one loop. So from here, lambda 3 by 2. And this is also a loop. So therefore lambda 3 by 2. And from here to here, it is again lambda 3 by 4. So the first point what we are going to mention under this is, in third harmonic, three nodes and 2 antinodes are formed. 3 nodes and 4 antinodes. This is 4, not 2. This is 4. 1, 2, 3, 4. Okay, 4 antinodes are formed. 3 nodes बनेंगे और 4 antinodes are बनेंगे. फिर उसके बाद जो है same process we need to follow, and let us see what we are getting here. So pay attention. This is what AB. Again, AB is equals to, we are getting L. So if you add all these, what we are getting, see, lambda 3 by 4 plus lambda 3 by 2, lambda 3 by 2, lambda 3 by 4, that is equals to L. Now, if you take the LCM 4, so this is what lambda 3, 2, 4 divided by 2, 2 we are getting, so therefore 2 lambda 3. Plus this is also the same thing, 2 lambda 3. When you divide this 4 by 4, you are getting just 1, that is lambda 3, that is equals to L. Simply we are taking the LCM, students, no need to worry about this. Okay, so what we are getting here is, this is 4. So if you see, this is how much? Lambda 3 plus 2 lambda 3 plus 2 lambda 3 plus lambda 3. That means it is 6 lambda 3. That only I am writing, 6 lambda 3 is equal to L. Now this is 3 times and this is 2 times. At the same time, just cross multiply it. So lambda 3, we are getting it as 2L by 3. Lambda 3 is 2L by 3. The same process we follow here. What we are going to write, that is again, V is equals to F lambda. So this is for third one. So I'll write like this. So F3 is equals to V by lambda 3. So V by, this is F3. What is V? Is as it is, lambda 3 is 2L by 3. So that I will write 2L by 3. Now this is F3 is equals to, if I take up, so this will be what? 3 times V by 2L. And you know, students, this is what? 3 V by 2L. Already we have calculated V by 2L as F1. So therefore I'll write here as F1. Now, if you observe, for the first harmonic, we are getting V by 2L. That is one time V by 2L. Here we are getting 2 times of V by 2L. Here we are getting 3 times of V by 3L. So what are the ratio of the harmonics? The very important conclusion I am saying, the ratio of the harmonics in the open pipe is always 1:2, 2:3, and so on. This is the last point, is very important, that I am writing here. Ratio of harmonics. So here it is 1:2, 2:2, 3:2, and so on. So I hope you have understood what is the fundamental frequency, that is the first harmonic, the second harmonic, and the lastly, that is the third harmonic.